Okay, let's go to page 126 and lesson 9.6. So this is on exponential form. So I kind of jump ahead already. So we kind of use a lot of exponential form already. And so this is what it's talking about. So when you have z equal to when you have a z equal to r cosine theta plus I sine theta, so the exponential form of that would be z equal to r e to the I theta. So this is your exponential form. So again, we already kind of covered that I kind of jump ahead in the previous section, kind of put everything together. Okay, so once you're familiar with how the exponential form operates, and you will apply over here. So let's go over example 9-8. So it says evaluate complex number. You got e to the. I don't like the way they do the slash, because the slash, you don't know if it's the following is part of the denominator or it's a separate. Okay, so my advice is stay away from slash. Okay, so this would be 3/2 plus I pi over 4. Okay, so basically this one you have two parts. You have the real part and the imaginary part. So if you were to separate, so this one actually has two parts. So you got e to the 3/2. Okay, when you are exponent, you can undo these, right? So it becomes e to the I pi over 4. Right? Again, when you multiply, you add, right? So we're just going backward to separate. Okay? So this one you cannot simplify. You cannot do anything to this already. So this would be just e to the 3/2. Okay? Now this one, to simplify this, I can just draw this out. Okay? Remember, this is the radius is 1 and the degree is pi over 4. So basically you have it right over here. So this is 1 and this is pi over 4. So this be square root of 2/2, square root of 2/2, right? So this is equal to square root of 2/2 plus I square root of 2/2. Okay? Okay, so again, this means it's 1. Okay? So 1 means radius is 1. Again, this is your radius, this is your angle. Radius and angle. So radius is 1, the angle is pi over 4. So you use your geometry, spatial triangle. Right? So it'd be square root of 2/2, square root of 2/2, and so this becomes over here. And remember, there's an I, right? Because this is in the I direction, and so that's what you're going to get for that. Okay. Let's go to page 127. In example 9-10, there are two very important equations that can be used to solve some of the problem. So on page 127. Example 9-10. Okay. Okay. You know that e of I x, okay, because the coefficient is 1, so you're going to get 1, right? So equal to cosine x plus I sine x. Okay. And so e to the I of negative x will be equal to cosine of negative x plus I sine of negative x. Okay, and so if you apply the negative function, so cosine of negative x is equal to cosine. See what happens if you look at cosine. So here's your x and here's your negative x. So for cosine, the negative angle does not affect the outcome. So it's still cosine of x. Now for sine, okay, so again, here's your x, angle x, negative x, but sine is over here for x angle, and the negative angle will give you opposite. So this becomes minus I sine of x. Okay? So again, for sine function, if the inside is negative, then it will become the opposite. So now if you look at these two equations over here, okay, if you add this together, this will cancel out. So if you add, this will cancel out. So you're going to get e to the ix plus e to the negative ix equal to 2 cosine x. And then you divide both sides by 2, so you got cosine x equal to e to the ix plus e to the negative ix over 2. Okay, so here's another expression for cosine of x in the exponential form. Okay, now instead of adding these two equations, if you were to subtract the two equations, okay, if you were to subtract, okay, so this is the important equation. So if you were to subtract this from that, so you're going to get e to the ix minus e to the negative ix. So this subtract, this will cancel out. So this will equal to 2I sine of x. Okay? And then divide by 2I. So you got sine x equal to e to the ix minus e to the negative ix over 2I. Now this one is not as useful because most of the time when you're dealing with this equation, this type of equation, you don't mess with the I. So this is more useful. You see this, you probably use this one more often than this one here. Okay.